this is Miss Schultz. All right, so find the slide where it says higher order derivatives. Okay, so we've taken one derivative so far, and we're going to learn how to take what's called the second derivative, the third derivative, etc. So here's the notation. There's equivalent notation. Y prime, you could also call this F prime, okay? Or dy dx. Those are both representing the first derivative of y with respect to x. The second derivative, you would write it as y double prime, okay? Or this. This is how we get this. Basically, so this is the second derivative. Y is the squared in different places, okay? This sort of explains why you have this is the first derivative, you're taking the derivative of y prime, okay? So you're taking I just think of it, let's just hop here. You're taking two derivatives, the derivative of the derivative, two derivatives, so the d is squared. And then the first time, the independent variable is x, and then the second time, the independent variable is also x. So both times it's with respect to x. It's with respect to x twice. So the x is squared. So the second derivative, d squared, and this means with respect to x twice. Okay? So for the third derivative, you would have f triple prime or y triple prime or d cubed y over dx cubed. But you wouldn't say it like that. You would just read all of these as the third derivative typically. Okay. The fourth derivative, you'd have y quadruple prime. At this point, you would start using Roman numerals, and in lowercase. So 4 in Roman numerals for the fourth derivative is IV. So we'd use a lowercase script I. I mean, you don't really have to use script, and a V. This is the fourth derivative, and then d to the fourth y over dx to the fourth. That would be the notation for the fourth derivative. It's like an exponent up there. Okay. You can take a look and read this mean. Love it. So in terms of how to find, we'll go over this in a second. In terms of how to actually find the second derivative, it's pretty simple. You find the first derivative, and then you take its derivative. That's the second derivative. To find the third derivative, you take the derivative of the second derivative, okay? So you just take your answer, the derivative, and take its derivative, and that's how you find the derivative of the derivative of the derivative, okay? So you could say acceleration is the second derivative of position. Acceleration is the second derivative of position. Okay, let's go down here where it says higher order derivative examples. We're going to skip this example, but we're going to focus on this function. P of x equals negative 2x to the fourth, etc. And I want to find the third derivative. So I'm going to start by finding the first derivative. First derivative would be negative 8x cubed plus 27x squared minus 12x. That's it. To find the second derivative, you would take the derivative of this. So let's think about what the second derivative would be. Okay, it's negative 24x squared plus 54x minus 12. All right, and now let's think about what the third derivative would be. Okay, it's negative 48x plus 54. That's it. Okay. Let's go over here to the next example. Find all the derivatives of y equals 8x to the fifth. So you're just going to use the power rule over and over again until you get to the derivative to be 0. Okay, see how the power rule and derivative notation works. Okay, so if y equals 8x to the fifth, dy dx equals 40x to the fourth. Okay, now go ahead, here's the question. Find the third derivative right now, okay? Find the third derivative. Okay, let's go over it. So 160x to the third. And 160 times 3 is 480 x squared. That's the third derivative. Can you now find the fifth derivative? Okay, let's go over it. That is 960x, 960. The sixth derivative is 0. So the seventh derivative would be 0, eighth derivative 0. All the derivatives here on out are 0. The 20th derivative would be 0, the 100th derivative 0, etc. Okay? All right, let's do some practice problems. APQ1 doesn't look that bad, but I do want you to listen and pay attention because I have some advice of how to do it. We haven't done one yet where we've evaluated at a number using the quotient rule. Okay? So I have some advice about how to substitute in to just be the most successful. So my question is, which rule do we use to do this? All right, it's the quotient rule because this is a quotient. There's division. There's a variable on top and a variable on the bottom. Okay, so I set it up low. It's my low, x plus 1. My high equals the numerator, x minus 1. D low, D high, 1 and 1. Okay, a lot of ones in this. All right. By the way, this is part of the domain. We know that the denominator can't equal 0 because there's a vertical asymptote there, or that would make the this is where the denominator is 0. But you can just kind of ignore this. You need to say this as a mathematician to make this mathematically correct, but it doesn't impact how you do the problem. This is what you want to pay attention to. So I highly advise to make, whenever you substitute in, okay, we're going to make a second chart. So I don't put this in the product rule yet if I have to sub in, and then in the quotient rule, and then sub into this like long, because you know how the quotient rule gets quite long, right? We're going to get to avoid that actually by just making a second chart with it plugged in. So we can see, let's plug in together. We can see that my low is x plus 1, and my 1 is x. My x is 1, so 1 plus 1 plus 1 equals 2. So this is 1 plus 1, 2. My high is 1 minus 1, which is 0. My lows are there. So now, or my D low and D high. So now when I do low D high minus high D low, look at how simple it is. Low D high, 2, minus high D low, 0, over low squared, so I get 2 over 4 or a half. Okay. Now, just for argument's sake, if I didn't remake this chart, this is what the problem would look like. X plus 1 times 1 minus high D low all over low squared. Okay, and then I would plug into here. This is like, all this writing is totally unnecessary if I plug in first and then do the quotient rule. Okay, so in terms of order, I want you to plug in, make the initial chart, plug in first, and then do the quotient rule. Don't do the quotient rule, then plug in. Okay? All right, let's do APQ2. APQ2 is tricky. All right, here it is. If u, v, and w, there's some like lighting issues, it's okay though, are non-zero differentiable functions, then the derivative of u, v all over w is which of the following? Okay, so my question is, which rule do I use? The answer is I'm going to use both of them, both product and quotient. Now, which rule do I use first? Quotient, okay? So I'm going to set up my quotient rule. Low, high, D low, D high. So be setting it up on your own sheet. Low is W. Okay. In terms of D low, W prime. Simple as that. The high is U V. Now what's my D high? Okay. My D high is, I have to use the product rule. U dv, instead of writing dv, I'm going to write v prime plus v du. Instead of writing du, I'm going to write u prime, okay? So this is u dv plus v du. So this is me using the product rule inside the quotient rule. Okay? Now let's quotient rule it up. So I'm going to have these two multiplied together. So it would be w parentheses uv prime plus vu prime. And this is the quotient rule. So low d high minus high d low uv w prime all over low squared. So go ahead and select which answer that is. Okay, it is E. Yep, it is E. Okay, let's move on to APQ3. There's a couple methods to do this. One we've learned, one we haven't. So we're going to use the method we've learned. Please use the quotient rule to do this. Set it all up, and then you're going to have to simplify, okay? I'm going to have you try the whole problem together, or on your own, and then we'll go over it together. All right, let's go over it. So low is 4 plus x squared, 2x. The high is 3, d low is 0. So low d high is 0 minus high d low, 6x, all over low squared, 4 plus x squared squared. Okay, so that would make the answer A. Oh, let me see. Okay, let's move on to APQ4 and then APQ5, and then we'll be done. Okay, what is the instantaneous rate of change at x equals 2 of the function? So when you see this phrase, that means derivative. Okay, at x equals 2 of this function. So this is another substituent. I want to start this together. Okay, I'm going to put it over here. Maybe out of the shadow a little bit. My low is x minus 1. What's my high? X squared minus 2. Okay, find the d low and the d high. They're 1 and 2x. Okay, now here's what I'm not going to do. I'm not going to go right to doing the quotient rule and write like parentheses x minus 1, parentheses 2x minus all this stuff. I'm not going to do that. Because I'm substituting in, I'm going to make another chart. Sub in x equals 2. Okay. So go ahead and make another chart where you substitute in, please, before we do the whole quotient rule formula. All right, let's see. 2 minus 1 is 1. 2 squared minus 2, that's 4 minus 2 is 2. And then 2 times 2 is 4. So now when you do the quotient rule, it's going to be pretty quick because you're doing it with numbers and not a long string of variables. So can you please finish it up and select the answer, A, B, C, D, or E. Just quotient rule from here. All right, let's group up. So I have 1 times 4 is 4 minus 2 over low squared, which is 4 minus 2 is 2 over 1 is 2. Okay. Let's do the last question. Okay. For this question, there's no rules other than memorizing your trig identities, or for now, if you probably don't have them fully memorized, looking them up. Okay. So here's how you're going to do this. You're going to take the derivative of tangent, y prime equals. So like, what's the derivative of tangent? And then cotangent, what's the derivative of cotangent? With a minus in between them, right? Then you select the answer. So make sure, before you go and do it, make sure whatever the derivative of cotangent is, like it's minus its derivative. Okay. All right, let's try it together. The derivative of tangent is secant squared x. You can just look that up. And then a minus. The derivative of cotangent, the derivative of any cofunction is negative. So the derivative of cotangent is negative cosecant squared x. You have minus a negative, so you have secant squared x plus cosecant squared x. That's what y prime equals, which is answer choice E. Okay, thank you so much. I hope this video taught you something, and I'll see you in class. Bye.